Hello dear students, I am Professor Onindo Dash from Achievers. In this video, we will be talking about data analysis in context to Raman spectroscopy. So, when we are talking about data analysis in context to Raman spectroscopy, there are four methods: inline, online, at-line and offline analysis. Okay, and Raman spectroscopy can be used in conjunction with each method to identify and characterize the chemical and physical properties of the materials in different ways. So you can use Raman spectroscopy in association with all these four methods of data analysis. Okay. At first, let us discuss the nuances of inline analysis. You can have a look into the instrumentation. Okay. Now, what is inline analysis all about? In this type of analysis, a solid state Raman spectrometer, this is a solid state Raman spectrometer, it is integrated directly into manufacturing or processing line. Okay. Allowing for real-time monitoring and control of the process. So, the industrial aspect has been explained over here. This approach involves continuously monitoring the Raman signal. It continuously monitors the Raman signal, there is a radar, during a particular chemical reaction or a manufacturing process, whichever is applicable. The Raman probe is integrated into the process stream, allowing real-time monitoring and control of the reaction. You have a probe, you have a Raman probe that is infused within the system, and that allows real-time monitoring and control of the reaction. So that's how it works. Okay. Next, we are moving on to online analysis. So you can have a look at the instrumentation. And my dear friends, online and inline analysis are almost similar. Only there is a certain difference, a small difference, a very small subtle difference is there. What is that? Online Raman spectroscopy is similar to inline analysis, but it is typically performed in a separate area adjacent to the production line. Online analysis is actually performed in a region which is separate, in a separate area, which is adjacent to the production line. It has to be adjacent to the production line. Okay. That means you don't have much of technical difference, just you have some industrial adjustments for that. The samples are transported from the production line to the Raman spectrometer through a sampling interface. Do you understand? Here, what is the difference in context to the inline analysis? The sole difference is that this online analysis is performed in a separate area which is essentially adjacent to the production line. And how this orientation is utilized? This orientation is utilized in this manner. The samples are transported from the production line to the Raman spectrometer through sampling interface. That's what is done over here. I think you all have understood. Next, we are moving on to at-line analysis. This is the wonderful picture of at-line analyzer. Okay. So let's have a look. At-line analysis, what is that? At-line analysis allows for more detailed and accurate analysis than online or inline analysis. When you are talking about precision, accuracy, you have to opt for at-line analysis. But the results are not immediately available. That's the con. of at-line analysis. In at-line analysis, you will be getting what? You will be getting more precise and accurate data in context to your inline or online analysis. But there is a con also associated with that process, and that con is it's very much time consuming. It's very much time consuming. Okay. In this type of analysis, samples are taken from the process tree manually and brought to a mobile Raman spectrometer for analysis. That's the sole reason why it's highly time consuming. Next, we are moving on to the final analyzer, that's offline analysis. Again, as we have seen, the online analysis is quite similar to inline analysis. Similarly, this offline analysis is very much similar to your at-line analysis. But there is a difference. Offline Raman spectroscopy is similar to an at-line analysis, but it is performed in a laboratory setting. This offline analysis, a picture you can see over here, it's there in a laboratory setting, whereas this at-line analysis, you can see it's present in the production site. That's the difference. That's the only difference you have. Rest everything is same. Offline Raman spectroscopy is quite similar to at-line analysis. In fact, the instrumentation, the technicalities are very much similar. The difference is the offline analysis is performed in a laboratory setting. Okay. A key difference is that offline analysis sometimes performed hours or even days after the sample was collected. I mean to say this is a difference, obviously a difference, because it is performed in a laboratory setting and some hours, even days is taken for after the sample was collected. That's a difference, obviously, but again there is a subtle similarity over here. As I've already told that this at-line analysis here, the results are not immediately available. This is very time consuming process. Similarly, offline analysis is also very much time consuming, very much time consuming. Okay. So now we'll summarize the advantages of different analyzers. So let's have a look. Advantages of different analyzers. The first one is inline. In inline, you have two advantages. The first one is real-time monitoring. This is the most important advantage of inline or online analysis. This is the most important advantage, the real-time monitoring. It gives you real-time monitoring. The real-time monitoring allows for immediate corrective action to be taken, reducing waste and improving product quality. You have the provision of real-time monitoring, and through that real-time monitoring, you can take immediate corrective measures, and that eventually reduces the wastage. Okay. The next, this approach is useful for studying the kinetics of a reaction or optimizing the reaction condition. That's quite natural. You have a real-time monitoring. You have a real-time monitoring of a chemical reaction, and as you have a real-time monitoring of a chemical reaction, so you can analyze the kinetics of a chemical reaction, because kinetics of a chemical reaction is nothing but it's monitoring the concentration of any chemical component participating in the reaction with respect to time. And if you can get a real-time analysis, then obviously you are equipped to study the kinetics of that particular process. So this is the advantage. Next, we are moving on to online analysis. That technique is quite similar to inline. Now here the sampling is done automatically. Sampling is done automatically and the analysis can be performed in a matter of minutes. That's the advantage over the at-line or offline analysis. In at-line or offline analysis, if you go for at-line or offline analysis, you look for accuracy, you look for precision. Here you'll get more precise result in offline and at-line analysis. Whereas in online or inline process, specifically in online process, the time taken is very low. You'll get immediate results. Here you get more accurate results, but not immediate results. On the contrary, here you will get immediate results. You will get immediate results. Okay, so sampling is done automatically and the analysis can be performed in a matter of minutes. So it's not time consuming. Instant results will be obtained. This approach is useful for quality control and batch to batch consistency in manufacturing process. Since the time scale is very low, so the process of quality control becomes very easier. Okay. Next, we are moving on to at-line analysis. The first advantage is this approach provides more detailed information about the reaction products. It can be used to identify impurities or contaminants. It's more accurate. So you have these advantages. Now, next, let us move on to the final offline analysis. This type of analysis is the most accurate and precise analysis. It's there in the laboratory setting, and we have already declared that this is meant for precision and accuracy. Okay, and the final advantage for offline analysis is this approach is useful for forensic analysis or for studying samples that can be easily analyzed in real time. Very important, forensic analysis. In forensic analysis, you don't have real time result. Suppose a crime has been committed in a particular site, and now you don't have the real time data of that, but you want a very precise data. Otherwise, you will not be able to crack the case. So that will be provided by offline analysis. That's what is important over here. So I think I have made this section absolutely clear to you all. Thank you all, and bye bye for now.